Thanks for joining in my YouTube channel. In this video, I am going to take you through the questions of Paper 2 JEE Advance 2024 Mathematics portion. Okay, and the first question that we are going to solve is this one. In this question, actually, we will use three main concepts which will be applied here. One is tan of tan inverse x is equal to x. The second is tan a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b, and third is the half angle formula, which is actually sine theta 2 sine theta oblique 2 cos theta oblique. Quickly apply these three and we will arrive at our solution. Let us assume this as a and this one as b. I will assume is sine inverse 3 oblique 5 is equal to a, and this will give me sine a is equal to 3 oblique 5, cos a will be 4 oblique 5, therefore tan a will be 3 oblique 4, and this will give a is equal to tan inverse of 3 oblique 4. Second, this portion 2 cos inverse 2 divided by a square root of 5 is b. This will give cos inverse of 2 a square root of 5 as b is equal to 2, and this will give cos b is equal to 2 cos b oblique 2 is equal to 2 divided by a square root of 5. Now you can easily get sine b oblique 2 from here, which will be 1 4 oblique 5 is 1 divided by a square root of 5. Therefore sine b will be 2 sine b oblique 2 cos b oblique 2. 2 is to a square root of 5 is to 2 a square root of 5. This is 4 oblique 5. Therefore, tan b will be 4 oblique 5 divided by 3 oblique 5 is equal to 4 oblique 3. This will give b is equal to tan inverse of 4 oblique 3. Now, we have to apply this in this formula, which is tan a minus tan b, and simply this will simplify to tan of tan inverse 3 oblique 4 minus tan of tan inverse 4 oblique 3 divided by 1 plus tan of tan inverse 3 oblique 4 is to tan of tan inverse 4 oblique 3 minus 4, 4 minus 3, 1 plus 3 is 2. This will become 1, and this gives us 9 minus 16 divided by 12 divided by 2 will be minus 7 oblique 24. Okay, I think minus 7 oblique 24 is an option which is given here. The option B will be the correct option. Okay, now let us go to the next question. Students, let us discuss question number second. Question number second is actually finding the area enclosed under a graph. So I'll take you to a graphing utility and let us discuss this case there. Okay. So these are the three graphs that the question is talking about. One is that this particular one is y square 12 minus 2x. This one is y square is equal to 4x. And this line is, in the question it is given less than or equal to sign, which actually means the graph lying under the area lying under this particular three enclosures. So the moment we draw the graph, we find the area enclosed between these two graphs, and these two graphs are from here to here, okay, enclosed between this sky blue and the green lines. And then there is a third straight line which is given here, this also passing through here, intersecting the earlier two graphs at one point and then passing through a point where it intersects this particular graph here. Okay, now it says x is also greater than or equal to 0 and y is also greater than or equal to 0, which means the question is interested only about the this first quadrant, okay, on the right uppermost of the graph. Okay, so what is the area which is enclosed in this? Is it very clear? This particular area, the question is talking about this and this, okay, this particular area. So how can we find this out? It is not very difficult, very easy to do that. Okay, we will use both integration and some logical thing to find out. First of all, the area enclosed in this area we will find using an integration of area A to B, which is y dx. Okay, and since the entire position lies on single graph, this one we can make use of this particular graph. And then for finding the area, this is very easy. This is actually triangle with units also given here from 2 to 5, and then this unit is given as uh, from y is equal to 0 to this point, which we can find by solving these two equations, which will come as 4x is equal to 12 minus 2x. This is x is equal to 2, and therefore y will be actually y square will be 2 square root of 2. Sorry, y will be 2 square root of 2. This will be 2 square root of 2, which will be 2.8 something. So we will use 2 square root of. So let us go to the original sheet for the finding this out. So area will be first A1. It is from 0 to 2, and graph we will make use of this. Y is equal to a square root of 4x, which will be 2 square root of x, 2 square root of x dx. This will be 4 oblique 3, 2 square root of 2 minus 0. Actually, friends, if you apply, if anyone applies his mind, actually we have already arrived to our answer. We need not do any further calculation for this. The first portion of the area has a denominator of 3, which means it is going to be in fraction like this. And both the area, if we add together, it could be either a multiple of 3 or it will be only 3. If it is a whole number, the second area, which is the triangle, if it comes a whole number, then the denominator will be 3. If it is not a whole number, the denominator will be actually LCM will be taken, which will be taken with 3 and other number, which means 3. The denominator should actually be a multiple of 3 here. And there is just one option where actually denominator is a multiple of 3 with 1, and which is option B. Rest 3 of them, they are not a whole multiple of 3, and therefore this situation will not arise. Okay, so intelligently, if you mark B, B will be the correct answer, but let us see by solving it, because I would also like to actually solve the problem and show it to you. So I'll find the area A2, which is the area of the triangle, and area of the triangle will be nothing but half is to base is to height, and half is this base is actually 5 minus 2, which will be 3, and height will be 2 square root of 2. So this will be 2, 3 is to 2 square root of 2, which is 3 square root of 2. Now area, add here this one, 8 square root of 2, 3 3 is a 9, square root of divided by 3, and this will be 17 square root of 2 divided by 3. Now this is actually alpha square root of 2 divided by 17 square root of 3, and this square root will go off and alpha will be actually 17 oblique 3. Correct option is B in this case. This is the third question. This question is again quite tricky, and we have to be very careful while actually solving this one. It says that this particular limit is given, and then e to the power x, we have to find a possible value of k among all these four options. The only concept used in this will be actually for an infinitesimal value of theta, or a very small value of theta. Actually sin theta tends to become equal to the theta. Okay, and that we will apply here. The first will become, this will become kx in the first go, and then it will leave us to sin kx, and then in the second go this kx will become just kx, and this particular value for a very small value of x will become 1, and then we can write x here, and 2 oblique x is equal to e to the power 6. This is what it is. Now, if you would have just seen the sequent and series, there is a formula called limit n tends to 0, 1 plus 1 oblique n is equal to e. Now, in this case, if we just reciprocate n, instead of n, if we write 1 oblique n, then this infinity will become 0, and this will become 1 plus n, and this will become 1 oblique n. This also gives us a value of e. We can actually apply the same thing here to get that. This kx plus x we can write as k plus 1 x plus 1 2 oblique x, or we can write 1 plus k plus 1 x 2 oblique x. In this case, friends, if you just go a little deeper into this, we find that if there is a multiple of a n right here, and then this is b oblique n, we get actually e to the power ab. Exactly same formula we will apply here. If x tends to 0, this will become e to the power this multiplied by this 2k plus 1, and this is given as e to the power 6 here. The exponent of these, both of them can be equated here. We can write k plus 1 is equal to 6, and this will give us a straightforward 3 minus 1, k is equal to 2. Our answer will actually become option number B. So let us move to the next question. So we have now arrived at our question number 4 in this particular section, and this is a conceptual question which is based on some statement. It is said that the function fx is given here. This is in two pieces. For x is equal to 0, the function is 0, and for x other than 0, it is defined by this one. And we have to check which of these are actually correct. The first of all, it is saying solutions, okay? Everywhere it is solution. Solution, when we get a solution, when fx is equated to 0, and for all the value of x that satisfy this particular equation is actually known as solution for this particular equation, okay? Now, in this case, fx is equal to 0 when we equate x square sine pi oblique x square, we will have to equate it to 0. This will give sine pi x square is equal to 0. Now we know one formula which is very common, which is sine n pi is equal to 0 and cos n pi is equal to minus 1 of n. We will use this one here, and this will be written as pi x square is equal to sine n pi. Now equate this, okay? We get pi oblique x square is equal to n. N is what? N is the number of nodes or a number of points where this particular graph crosses the x-axis or it touches x-axis, where where the value of y or value of fx becomes 0. And this is the number of solution that we are looking at. So our number of solution is actually defined by n is equal to 1 oblique x square. With this, we can check which of these are correct. First set is the infinitely many solutions in interval this. Okay. Let me check. For the lower interval, the n will be 1 oblique x, 1 oblique 10 to the power 10 square is equal to 1 oblique 10 to the power 20. This is 10 to the power 20. This is a finite number. And the second one, if we put here, I mean, we need not spend our time in that. The moment we apply infinity here, this will actually become 0. The n is equal to 0. So it says infinitely many solutions between 0 and this point, which is not correct because n will not be a fraction. N is a proper number. Number of solution is natural number, okay? And natural number between two finite points will be a finite number. Then this is incorrect. Infinitely is not a right statement for this. There will be finite numbers of solution. It might be very large, but it will be definitely a finite number of solution. Now, what is the second option? Fx has no solution in interval. This will straightforward looks incorrect because the moment n is equal to x square, the moment we put 1 oblique pi, n will get as pi square, which is a number very close to 10. Which means there will be some solution in this interval. It is not that there will not be any solution. So this is also incorrect. These are discarded. The set of solution in the interval is finite. This is again, this will become infinity and this will become 10 to the power 20, just opposite of this. And this is the set of solution in interval 0. If we take 0 here and a square, this will become actually infinity. And so it will have infinitely many solution on one side. Therefore, the finite is actually not right answer for this. And the set of solution, it is saying the set of solution will be actually infinitely very large. This is again incorrect. Now let us check what the last one, okay? N is equal to 1 plus x square. If I take the first bound, which is 1 oblique pi square of a square, this gives pi oblique 4. Pi oblique 4 will be a number which will be close to 100. The second is n is equal to 1 oblique pi square, which is actually pi square. This is a close number to 10, which means it says the f has more than 25 solution in the interval. If we look at these numbers, actually the number of solution in this interval will be approximately 90. Approximately 90, I am saying, not 90 is definitely a number which is greater than 25. Therefore, our option in this will be, the correct option will actually be option D. So, we will solve this particular question number 5 from JEE paper, Advance paper 2, and this is conceptually a very complex question where it says that limit of this limit to infinity is equal to 0, and we have to find what could be the value of alpha and beta as a set of this. This alpha beta is saying that is in R2, means it's a real number in 2 coordinates. I mean, okay. So if suppose alpha is on x, the beta will be on y axis, something like that. So we will try to solve this. First of all, I can write sin x square log e. I will add x square here, alpha beta x square. Then in order to neutralize this, I will put 1 oblique x square. This is limit x tends to infinity. Now I can segregate it. Limit x tends to infinity sin. As per the rule, the limit can be applied separately on this particular portion, and when limit is applied, x tends to infinity sin, this will result into 1. Since we know limit theta tends to 0, sin theta oblique theta is equal to 1. When the value of theta is infinitesimally very small, the value of sin theta almost becomes equal to theta, and therefore it will result into 1. Which means this can be removed from this particular equation and it will become, we already know that this expression is equal to 0. We have to find what possible value of alpha and beta could be there which will make this expression equal to 0. Since x square tends to infinity, if we put sign, the value will actually vary between -1 and 1. But these two can go up to infinity, okay, when we substitute the value of infinity. So what can be done? We can check x should not be in the numerator. For which we will check alpha is equal to all four of them and see how it works. So first we will take alpha is equal to -1 and beta is equal to 3. This will give sine x square log e x minus 1, and this is x minus 3 here, minus 1 multiplied by 3 plus 1. Okay, log e, this is 3. Students, you find that both x and log ex, both of them are in the denominator, which will make this expression undefined, and it will not be, we cannot say that is equal to 0. Similarly, let us check alpha minus 1 beta 1. Okay, let us substitute this. Minus 1 is to 1 will become minus 1 plus 2, it will become x. This will, with limit x tends to infinity, this will actually work out, because when infinity is there in the denominator, actually this will become equal to 0, which is actually our requirement. Therefore, one of the option for this is actually minus 1 and 1, okay, belonging to real number. Similarly, we can check with 1 and minus 1, and this will be again and this, there will be one x in the denominator, which will make, when it goes x to infinity, it will make this equal to 0. So the our equation will get satisfied. And with 1 and minus 2, if we check this one, this will become minus 2 plus 2x is equal to 0, and therefore there will be nothing in the denominator. Hence, this will become actually equal to infinity, and equal to infinity is not a option which we can take, because we have to find this is equal to 0. The third option will, fourth option will not be correct. The only two options which will be correct in this case will be B and C. Right, students? So let us move to the next question now. So we have come to question number 6. This is pretty straightforward. It says that a straight line drawn from this point, which is actually parallel to this line, okay, intersect L1 at Q. So first of all, actually we have to find point Q. This is one of the requirement. Once we know point Q, we will be able to find the distance of PQ. Another straight line which passes through Q is perpendicular to L1. So we have to find one straight line which is actually perpendicular to this particular line, and that particular line intersect this one at this point, which is R. We need to actually find out Q and R both in this question. The equation which is parallel to this one and passing through this will be x minus 1, and we take the directional coefficient from here, and y minus 3 divided by 2 and z minus 2 divided by 1, and we will assume this equal to k, which is actually a constant. Hence, x will become k plus 1, y will become 2k plus 3, and z will become k plus 2. Now these values of x, y and z will satisfy this particular plane at this point at Q. So we can substitute this here. This will be k plus 1 minus of 2k plus 3 plus of 3 of k plus 2 is equal to 6. This becomes k plus 1 minus 2k minus 3 plus 3k plus 6 is equal to 6. And this will give us, and this is 2k minus 1 plus 2k minus 2 is equal to 0. This will give k is equal to 1. So the point at which it actually intersects the Q will actually be 1 plus 1, which is 2. Q will be, this is 1 plus 1, 2, and 5, 2 plus 3, and 3. Now there is one more line which is actually passing through point Q and intersecting this particular a straight line perpendicularly. It is saying that and is perpendicular to plane L1 and intersect at plane L2. Okay. Another straight line which passes through this point, that particular we can take the directional cosine from this one, which is actually multiple of A, B, C, The directional cosine of plane L1 is actually 1, minus 1 and 3. Okay. And here we can take a line which is passing through this point. X minus 2 divided by 1 is equal to y minus 5 divided by minus 1 is equal to z minus 3 divided by 3. This is the line which will be actually passing through point R, and this is the line which will be passing through point Q and will be perpendicular to L1. Now it says that it is intersect the plane at point R. We will do exactly the same thing by assuming a directional cosine. I will assume here alpha, and this will become x is equal to alpha plus 2, y is equal to minus alpha plus 5, and z is equal to 3 alpha plus 3. And then we can substitute in the second plane, which is L2, and we get 2 alpha plus 4 minus of minus alpha plus 5 plus 3 alpha plus 3 is equal to minus 4. This gives alpha is equal to minus. So point R will be actually minus 1, R will be minus 1 plus 2 is 1, minus 1 minus alpha is plus 5 is 6, and this is 0. So we have 3 points P 1, 3, 2, Q 2, 5, 3, and R 1, 6, 0. Now the length of the line segment PQ. PQ is 2 minus 1, 1 square, 5 minus 3, 2 square, plus 3 minus 1, 1 square is a square root of 6, which is perfectly correct. This option is correct. The coordinate of R is 160 and not 163. This is incorrect. The centroid of the triangle is 4, 3, 14, 3. Okay. Centroid will be x bar, x1 plus x2 plus x3 will be 3, 1 plus 1 plus 2 plus 3 is equal to 4 oblique 3. Y bar is 3 plus 5 plus 6, 14 oblique 3. Z is equal to 2 plus 0 plus 3, 5 oblique 3. If this is correct, this is also correct. The perimeter of the triangle is a square root of 2. Perimeter will be distance of PQ1 we have calculated. PR will be 1 minus 1, 0 square, 6 minus 3, 3 square, 0 minus 2, this is 11, and QR is 2 minus 1 is 1 square, 1 square and 3 square. 1 plus 1 plus 9 is 2 minus 1 square minus 5, 1 square 3. This is also 11. So PQ, PR and QR 2 minus 1. So this is incorrect. The correct option is actually only option A and option C. So friends, we have come to question number 7, and question number 7 is from geometry. We have to solve this question using graph. I think without that it would be difficult. What I'll take you to a graphical calculator and later, and then we will discuss this there. As per the question, this graph is actually y is equal to 8x, which is nothing but it is 4ax. If we compare here, we will have a is equal to 2, so we can write 4 is to 2 is to x. And this is point B1, or this is point A1, this is point B1, and this is C1. It is saying that the coordinate of C1 is minus 4 and 0, and we have to find the coordinate of both A1 and B1. It is given that these lines are actually tangent to this parabola, which means we have to find the position of the tangent, okay, tangent line. We know for a parabola, the equation of the tangent is given as mx a plus m. This can be written as y is equal to mx. We know for us a is equal to 2, so we can write m is equal to 2. And another method is to find by differentiating this equation, where actually m is dy oblique dx. First of all, we will find m by differentiating this and assuming a point. Based on this, what I'll do, I'll assume this point as 2 alpha square, and when we substitute 2 alpha square in place of x, we get 4 alpha here, and the second value will be minus 4 alpha. And as this intersection is taking place on the x-axis, the 2 alpha square comma minus 4 alpha will be coordinate of nothing but v1. So we can write 2 alpha square minus of 4 alpha. Okay. And then 2y dy is equal to 8. This will give us 4 oblique y. Y we will be 2 square root of 2 square root of x. This will be x. Okay. Let us go to the original sheet now. We have dy oblique dx is equal to 4, 8, 2 square root of x, which gives nothing but, substitute x is equal to 2 alpha square, we get 1 oblique alpha here, and the equation of the tangent is mx plus 2m, and this will be x oblique alpha plus 2 alpha. Now it is saying this particular tangent is also passing through this point, which means this point will also satisfy this line, and therefore we can substitute x is equal to minus 4 here and y is equal to 0. So we get minus 4 alpha plus 2 alpha, and this will be nothing but alpha is equal to, alpha square will be actually 2. Alpha will be plus minus 2. Now once we have alpha, this becomes very easy. We can just substitute plus minus. This gives us a slope of m is equal to plus minus the square root of 2. Now, since we had assumed, here we will not be requiring the slope as such. We had assumed the points as 2 alpha square, 4 alpha. So one of the position, which is A1, it will be actually 4, and 4 alpha will be, B1 will be 4, and this will be minus of 4 square root. Now we have to address this question. So length of the line segment OA1 is, O is 0, 0. So it is asking the position of this from the point 0. So we can get it like when this becomes 16 is to 3 is equal to 4 square root of 3, which is actually correct. Option A is correct. Now what about other option? The line segment, the length of the line segment A1 and B1. The length of the line segment A1 and B1 is nothing but this line, and this is actually minus 4 square root of 2, and this is plus 4 square root of 2. This will be nothing but 8 square root of 2. Therefore, and B1 is 8 square root of 2, so this is actually incorrect. Now what will be the orthocenter of the triangle? This is a very interesting question here. Actually, this form a triangle A1, B1, C1. It is asking orthocenter of the triangle. As we know, the orthocenter actually lies on when we actually draw what you call the perpendicular on the sides, and the point on which the perpendicular line intersect each other is called orthocenter. Actually, the easiest way to find the orthocenter is actually to draw tangent from tangent on a side from the opposite angle or opposite point, and then solve two of them and find out at what point they are actually intersecting, and that particular point will actually be an orthocenter. So in order to find the orthocenter, I'll just remove this from here, and the first line for us is the tangent line here is just y is equal to 0. Not tangent line, the line which is actually passing through the point C1 and making a perpendicular degree with the side A1, B1 is y is equal to 0. Similarly, a line which is passing through point 1 and making 90-degree angle with side A1, C1 needs to be found out. Okay, and therefore we know this point is 4, 4 alpha 2, and this is perpendicular. We have, if this is say AB, which means, so we have to actually find a line which is making a 90-degree angle with side B1 C1 and passing through point A. And once the equation is found out, we need to solve this with y is equal to 0 to find the orthocenter. Okay, so in this case, what we can do is the line which is actually perpendicular to B1 and C1 will have a slope of minus of 1 oblique m. Here we already found out that the slope is minus of 1 oblique square root of 2. So the slope of line A1 and B1, for a timing I am assuming, that will actually become m1 is equal to minus of minus square root of 2. Okay, so we have a line which is the square root of 2x plus c. This line is actually passing through 4 and 4 root of 2, so we can simply substitute it here to get plus c will be actually 0. So we have a equation which is, this particular line has no intercept. It is actually passing through origin, passing through origin of the graph or 0, 0, and there is no need to solve it also. We are straightforward get it. If we put y is equal to 0, x will be 0, which means these two lines are actually intersecting each other at origin, and we get orthocenter as 0, 0. Therefore, our orthocenter will actually here will be 0, 0, and there cannot be two orthocenters of the same triangle, which means the option D will be incorrect. So in this case, option A and C are correct options, A and C. Right, friends? So I'll move to the next question now. So in this we will attempt question number 8, which is based on function broadly, and there are two conditions given here. If you see a function which satisfies this particular equality can actually be written as fx is equal to kx. Okay. Similarly, a function which satisfies can be written as gx is equal to a to the power x. Now, if you want to check whether this particular thing is correct or not, we can simply put x plus y in place of x, and we get kx plus y is equal to kx plus ky, and we had written fx in place of kx, so we can write fx in place of this, we can write fy. Similarly, if we replace x with x plus y here, we get, this is nothing but a to the power x multiplied by a to the power y, and a to the power x, just now we got gx, and a to the power y therefore will be gy. So in order to solve this problem, we will assume such a thing, okay, and we will assume and solve. It is not very difficult. Let fx be kx and gx be a to the power x. It is saying that f minus 3 oblique 5 is 12. If we put the value of minus 3 oblique 5 here, this will be minus 3 oblique 5 of k, and this is equal to 12. Then k becomes how much? Minus 20. Similarly, g of minus 1 oblique 3 is 2. This is equal to a to the minus 1 oblique 3. This minus 1 oblique 3 we can write as 1 oblique a to the power 1 oblique 3. This is equal to 2. And if we make cube of both the sides, this will become 1 oblique a is equal to 8. Therefore, a will be 1 oblique 8, right? So we got k is equal to minus 20, a is equal to minus 1 oblique 8. So our function actually will become fx is equal to minus 20x, and gx will become 1 oblique 8 to the power, and we have to find f1 oblique 4 and g minus f oblique 4. 1 oblique 4 will be simply minus 20 multiplied by 1 oblique 4. This will give us minus 5, and this is minus 2, it is saying. So we can write g minus 2 is equal to 1 oblique. This will be nothing but 1 oblique 8 square, and this is 64. So we can find this one, and g0 will be what? We have to find g0 as well. g0, the moment we put 0, this will become 1. we have G0 is equal to 1. So first of all we have to find 1 oblique 4 here minus plus G minus 2 minus 8 and then G0. 1 oblique 4 is minus 5, we can write here, plus G minus 2 is 64, we can write here minus 8, and G0 we have just computed as 1, so this will become 13, 51. The correct answer for this entire expression will give us a value of 51. This is the right answer. Thanks a lot. Let us go to the next. Now friends, we have come to the next question now. This is from probability. This is also appears to be very straightforward in terms of the question, but let us see. Actually, the formula for this will be is equal to P W1 G2 B3. Okay, how do we find this is given, and we have to find this one from the given information and then solve the equation. So this is 2.9 is equal to G2 is equal to 2 oblique 9. This will be how much? 3 balls. We have assumed n balls total. Here total balls are n. So first we will have to pick up the white and then green. Out of n we take this one 3 oblique, and then the number of balls remains in the bag will be n minus 1, and the probability of this occurrence will be n minus 1 is equal to, this is how much it is given as, this will be 2 oblique n minus 1 is equal to 1 oblique 5, and this gives n minus 1 is equal to 5 is to 2 is equal to 10, n will be 10 plus 1. The answer for this will be n is equal to 11. Now we have come to question number 10. Question number 10 is also not very difficult if we see previous year question of advance from the mathematics subject. This is asking for how many number of solution will be there for this particular equation. If we look at the denominator for both of them, it is same. The fx can be written as actually sine x plus 2, and take this particular expression as common. Neither this will be 0 nor this will be 0, because otherwise the expression will become undefined. So we straightforward say this is x is equal to not 0, and this is also not 0. It will not offer any solution when we compare with 0. Either sine x plus 2 should be 0 or this should be 0. This will never be 0 because the range of sine x is actually minus 1 to 1. So it will never be equal to minus 2, and hence it will never be 0. So this also offers no solution for us. We have just remained with this expression 2023 plus 2024x plus 2025 is equal to 0. Now, in order to see how much solution it will give, we need to actually differentiate this to find 2023 x 2022 plus 2024 is equal to f prime x, or f prime x is equal to, looking at it we can clearly find that this is actually for all value of x it is going to be positive, because this expression will never be negative since it has a even value on the power of it. Okay, so this will always be greater than or equal to 0. We can say then the function is strictly increasing, and when the function is strictly increasing, this particular equation at the most will have just one solution. Okay, then the number of solution of fx is equal to 0 will be just 1. Right friends, so let us move to the next question. And you can see the solution also. Just substitute x is equal to minus 1, and you will find minus 1 here because this is an odd power. This will actually result into minus 1, minus of 2024, and this is nothing but minus of 2025, which will be set off by 2025, and it will give 0. Hence, x is equal to minus 1 is just one solution for this particular given expression. We have come to question number 11 now, and this is actually not very difficult. You have to just segregate. Okay. So now what we have to do is we have to equate I with I, J with J, and K with K with the equation which is given on the right side. So we get first equation 5 alpha plus 4 gamma is equal to 15. Then we get alpha plus 3 beta here J, and then gamma is equal to 10, and then we get 7 alpha plus beta minus 3 gamma is equal to 6. Now what I'll do, in order to eliminate beta from there, let us multiply equation 2 with equation 3 with 3, and this will become 21 alpha plus 3 beta minus 9 gamma is equal to 18, and subtract this one, which is alpha minus 3 beta, alpha plus 3 beta plus gamma is equal to 10. When we subtract, we get 20 alpha minus 10 gamma is equal to 8. This will give us 10 alpha minus 5 gamma is equal to 4. From here we can make you multiply it by 2 and then eliminate alpha easily. 4 30 minus 8. Now this will be 13 gamma is equal to 26 and gamma is equal to 2. Here the equation will be 2. This is the correct answer for this one. Okay. Let us move to the next question now. So friends, we have now arrived to question number 12, which is actually a question from conic section. And there is a parabola which is given here, and there is a point where there is an unknown we have to find. And A also we have to find. A is not given. Okay. And there is a line L which is passing through this particular point but is parallel to the directrix of the parabola. Okay. So in this case, the directrix of the parabola will be y is equal to a. I will use a graphical template to actually explain in a much better way. Okay. This is the parabola which is x square is equal to minus of 4ay. Okay. And then this is the origin 0, 0. And this particular point will be, since it is saying x is equal to 0 and y is equal to minus of alpha, 0 minus alpha. This is origin. It will be, x will be 0 means it will be on this line, and alpha will be a value alpha in the negative direction. This becomes 0 minus alpha. Now as per the question, there is a normal drawn from this point to this parabola. Okay. And we have to suitably assume a point here which actually gives us the location. I will assume 2AP and minus AP square. If we substitute 2AP here as the value of x, the value of y we will get as minus AP square. This is being assumed this way for convenience in actually solving this particular problem. Okay. Now we have to find the slope of this line. Slope will be what? The slope of the tangent line is dy oblique dx, and the slope of the normal will be actually minus of 1 oblique dy oblique dx. So first of all, let us find dy oblique dx for this. X square is equal to minus of 4ay. Point that we have assumed is 2AP minus AP square, which is on the parabola here. So this will be 2x is equal to minus of 4a dy oblique dx, or dy oblique dx will be minus of x oblique 2a. Substitute the value of minus 2a, value of x here, we get minus of 2AP oblique 2a, or minus of p. This will be actually tangent of the slope of the tangent at this point. Now the slope of the normal will be, I will take it m1 as and this will be nothing but 1 oblique p. 1 oblique p is given as 1 oblique x square root of 6. Okay, so we can say that p is a square root of 6. Now we have one more equation of the line. Equation of the line is a line passing through this point and this point, and from here we can actually get the slope of this. So usually what will be the slope of this line? It will be actually dy oblique dx will be y2 minus y1 divided by x2 minus x1. I think this is the formula that we use. Therefore, dy oblique dx will become minus of ap square minus of minus alpha divided by 2ap minus 0, or alpha minus ap square divided by 2ap. And this is how much? This is, here if we look at it, this is actually minus of 1 oblique p, or 1 oblique. Okay, this will be nothing but minus here. This will be slope of the line. Slope of the line is actually slope of the normal line. Okay, so here there was a mistake which I have corrected. This will become alpha minus ap square divided by 2ap. pp will cancel each other out, and alpha plus minus ap square will become 2a. We just computed p will be square root of 6, hence p square will be what? 6a. Alpha will become 2a plus 6a, 8. Now what is the question? Question is saying that the line L1 is passing through this particular line and parallel to the directrix. Okay, we understand that. It is talking about a line which is shown here in green, and this is parallel to directrix. In this case, the directrix will be y is equal to a. So we have to actually find out this value. Okay, so we will be able to know the coordinate of this, and what is going to be this particular value. We just computed alpha will be 8a, and this is what? This is negative 8a. This is alpha. Here actually if you look at from origin, this is 0 and this is minus alpha, which means this is actually minus 8a. So alpha is equal to 8a, therefore we can use a is equal to, or alpha is equal to minus alpha is minus 8a, and that distance we have to take. X square is equal to minus of 4a is equal to x is alpha, and alpha is minus 8a. This will become 32a square, and x will become the square root of 2a. There will be two values of actually x here. One will be this side and another will be this side. So this side will, x will be positive. We can take it here 4 square root of 2a, and this will be minus alpha. Minus alpha is minus 8a, and this will be minus 4 square root of a and minus 8a. This becomes the coordinate of these points. 4 2a minus of minus 4 2a, this becomes 8 square root of 2a. So AB is actually 8 square root of 2a. R denote the length of the latus rectum, and S denote the square of the length of the line. So we have already computed the length of the line, which is AB. So S is nothing but AB square, and this is nothing but a square root of 2a square. And for this latus rectum will be, the length of the latus rectum will be 4a. Okay, this is R, this is 4a. So as per the question, R oblique S is 1 oblique 16, which means 4a oblique, this square is 128a square is equal to 1 oblique 16, and this is nothing but, and this is 64 divided by 2. This will give us 1 oblique 2a is equal to 1. This will give a is equal to half. Okay, when a is equal to half, 24a is equal to 24 is to half is equal to 12. Therefore 12 will be the correct answer for this. In order to understand, you can take a print copy of this. In case, you can pause the video and you can take the print of this one, and this will be helpful for you to understand how this conic section has worked. Okay, let us move to the next question now. We have come to question number 13 now. 13 number question appears to be a little conceptual, so we will try to actually segregate it. It is saying that if the value of t which is given here, and when the value is actually a natural number, the resultant is actually an integer. Otherwise, it is this function. Okay, and the range is actually given for this. The interval is given for this is open bracket 1 to 8 included, which means we may start with 1, but we have to take only till n is equal to 7 or n is equal to 8. Okay, let us see how it works. For n is equal to 1, t will be 1. Okay, so what will be ft? Ft will be minus 1, 1 plus 1, which is a square 2, or this is 2, for t is equal to 1. Okay, what is going to be next number we take will be actually n2, because natural number will be n1, n2, I mean 1, 2, 3, 4, like that. So n2 will give us t is equal to 3. For t is equal to 3, the value will be actually minus 2 here. And what will be the value in between 1 and 3, which will be represented by this function? And if we simplify, we can get it from here. This will actually be, for t is equal to anything other than 1, this will be, for n is equal to 2, this is 2 to the 4, 5 minus t. This will be 4 minus 2t. For 1, t, 3. This will be, the moment we take t is equal to 3, it will become 3 plus 1 is 4 and 2. This will be minus 2, t is equal to 3. Minus 8 minus 2t for 3t, 5. This will be 2 for t is equal to 5, and 12 minus 2t for minus 2 for t is equal to 7, and then minus 16 plus 2t will be for t is equal to 7. Now it is saying alpha denotes the number of solution equal to G0. G0, the moment we do it here, actually it comes as fx as a constant. Given is gx is equal to ft dt. The moment we differentiate this, gx is equal to fx, like this. And when gx is 0, the integration of means 1 to x fx ft dt is equal to, this is 0. Which means capital Fx is equal to a constant. Now, what is the solutions are already listed here. We have to take solutions for number greater than 1. For 2, we will not get, what we will get is for 3, 5 and 7. For 3, 5 and 7, minus 2 is one solution, 2 is one solution, and minus 2 is one solution. So there will be total 3 solutions. Alpha will be 3. Now we have to find beta. Beta is actually limit of x tends to 1 from plus side, gx dx oblique x minus 1. And we know gx is, apply L'Hopital rule here, we get limit x tends to 1 plus g prime x divided by 1. And we have to find g prime 0 here. What will be the g prime 0? Not g prime 0, rather g prime 1 plus. This will be g prime 1 from plus side. And here if you look at this, if we approach 1 from the plus side, which is actually an open bracket here, we get 2 as a solution for us, which means this will actually be 2 divided by 1 or 2. We got alpha is equal to 3, beta is equal to 2, therefore alpha plus beta will be 3 plus 2 is equal to 5. The 5 will be our answer for this. Okay. So let us move to the next question now. So question number 14 is based on set theory. It's a very fundamental question. We have to find the number of possibilities n which will hold this particular conditions. Okay. There is a set which is given which is nothing but first 6 natural numbers, and there is a set R. R has these two conditions. One is that it has exactly 6 elements, and the numbers are such that the difference between any two numbers is greater than 2. I will tell difference between any two numbers is greater than 2 because this is absolute. Okay. So, what are the possibilities that is going to exist for this? We have to find this much only in this case because nx is given as mc6 and we have to find the value of m, which is finding what is the total number of possibilities. So, in this case, what we will do is let us form 1, 2, 3, 4, 5 and 6, and when y, which has the range of R has just one element, we will take range as 1, then our possibilities will be 3, 4, 5, 6, because the difference is greater than or is equal to 2 in this case. The moment we take 2 here, the difference between 2 and 1 will remain 1, which will actually violate this particular condition. For 2, this is 4, 5, 6 only. For 3, it is 5, 6 only. For 4, it is 6 only. Now, since this is given in absolute, okay, there will be two conditions. One is a minus is greater than 2, or second will be b minus a greater than or equal to 2. Which means this will actually reverse in one case. The number of possibility will become 4 is to 2 here, 3 is to 2 here, 2 is to 2 here, and 1 is to 2 here. This is total number of 20. The total number of possibility m will be actually 20. Our answer will be 20 will be the correct answer. So let us move to the next question. In this case, actually, we computed the total possibility m is equal to 20, which means x is equal to actually 20c6. Okay, and whatever condition is given based on that, the total number of conditions that satisfy this particular first one is 0, and this will be then computed as we have to compute nz as 1 will be 3, 4, 5, 6 as we computed earlier. 2 will be 4, 5, 6. 3 will be 1, 5, 6. 4 will be 1, 2, 6, 3. Okay. Now total number of possibilities will then actually be n4 is to 1 multiplied by 3 is to 1 is to 3 is to 1 is to 1 was left actually. I will put it here. 1, 2, 3, 4. 4 is to 1. This will become nothing but 4 is to 3 is to 3 is to 3 is to 3 is to 4, or 3 is to 3 is to 4 whole square. And this is actually equal to ny oblique plus nz is equal to k square, which means 0 plus 36 square is equal to k square. This will give modulus of k as 36. So our answer for this will actually be 36. So we have actually come to question number 16 here, and the question is actually about a function and integration, and the function fx is actually defined by this one and gx by this one, and we have to find fx gx oblique dx minus 2. It might require a little bit of trick to actually do it. First of all, we do this one, which is actually 0 to pi oblique 2, and fx is sine square x, and gx is a square root of pi x minus 2 x square. Let us assume this as I. Okay. And actually, whenever there is something given in a square root and an integration is involved, we can always see if the expression which is given inside the square root can be made a perfect square or part of perfect square. And it appears that here actually we can make that pi x square oblique 4 if we write and then multiply with 2, and this is minus x square, which means if we put something like pi oblique 4 square and minus of 2 pi x oblique 4 plus x square, and then, or we put this as a plus and then we subtract this, No, it will not be plus. It will be actually minus, and this will also be a minus. So if we, this is exactly what our expression is going to give us. So we can write this as pi oblique 4 minus x. This will be pi oblique 4. This is perfect. So we can write pi oblique 2 sine square x. Now we can use King's formula, or we call it King's, whatever name you want to give it, and apply sine square of pi oblique 2 plus 0 minus x, and here we apply pi oblique 4 square minus pi oblique 4 minus of pi oblique 2 plus 0 minus x, and this is a square dx. This will be 0 to pi oblique 4. This will be cos square x, and this will be minus of minus pi oblique 4. This is nothing but, since this is in a square and this is in negative of this, this particular expression is just negative of this, and in this square it will become equal to this only. We have actually pi oblique 2 cos square x and pi oblique 4. Okay. What we have got, we have got one in sine and one in cos. We will add both of them. 2I will become 0 oblique pi oblique 2 sine square x plus cos square x, and this will become pi oblique 4 square, and this is 1, and this entire expression here is actually equal to gx as given above. The moment we simplify it, we will get this particular expression. Okay, and therefore, or in case you want to simplify and see, I can just do this for you. Pi oblique 4 square minus of pi oblique 4 square minus 2 pi x oblique 4 plus x square dx, or this becomes 0 pi oblique 2. Once we remove the bracket, the signs will change, plus 2 pi will become pi x oblique 2, and this minus will make this particular sign minus. This is actually equal to gx. Now what we have to compute in this, it is saying to find 2 fx gx dx. So we have just now find out that 2i is equal to gx. 2i is equal to gx, and what will be the 2i? We had assumed I is equal to 0 oblique pi sine square x, and okay. So we have now got 2i is equal to gx, which means 2, the moment we multiply 2 here, it will actually become equal to gx, which means 2 0 to pi fx gx dx is equal to 0 oblique pi oblique 2 gx dx, and hence this minus this is equal to 0. Our answer will actually become 0 for this. So let us see the next question. Now friends, we have come to question number 17, which is actually last question. Okay, and this is the question, this is the second part of the same paragraph as each question. Earlier we did, and we found out that 2i, where actually I is this, is equal to gx, when actually, which means 0 oblique pi 0 to pi oblique 2 fx gx dx is actually half of 0 to pi oblique 2 gx dx. So in order to compute this one, we can compute this particular portion, and let me assume this as I2. Okay, I2 is actually half of 0 to pi, and we take gx from here, and I will straightforward put the one trick or assumption that we used in last question. Okay, this is actually what we have to compute. It's quite simple. What I'll do in this case, pi minus 4 of minus x, pi divided by 4 minus x, I will assume as pi oblique 4 is to sine theta, This will give me minus dx of pi oblique 4 cos theta d theta, and then dx is equal to minus of pi oblique 4 cos theta d theta. Substitute this here, and in case you want to change the bound also, you can do that. Use x is equal to 0 and sin theta will be 1 and theta will be pi oblique 2. Use x is equal to pi oblique 2 and this will be minus of pi oblique 4. Sin theta will be minus 1 and theta will be minus of pi oblique 2. So integration will become I2 half of pi oblique 2 to minus pi oblique 2 divided by pi oblique 4 square minus of this one, and dx will be again minus of pi oblique 4 cos theta d theta. I can take pi oblique 4 whole square outside and it will give me just pi oblique 4, and here this will be 1 minus sin square theta and this will become cos theta, and this minus also I can take it outside. I can write minus of pi oblique 4 in multiple here, and this will become cos theta d theta or cos square theta. This is pi square 32, and if I reverse the order, the sign will also change. I will reverse the order and make it minus pi oblique 2 to pi oblique 2. This will become minus of cos square theta d theta, or pi square 32 cos square theta can be written as 1 plus cos 2 theta divided by 2 d theta, and the integration will become this 2 I take it outside. Pi square is equal to divided by 64, 0 to pi oblique 2 theta. I will straightforward write the integration. This is 64 theta. This will be sine 2 theta divided by 2. There is 2 we have already taken out, so this will actually simply become sine 2 theta divided by 2 minus pi by 2 to pi by 2. Okay, this is nothing but at both minus pi by 2 and pi by 2, sine 2 theta will become sine pi and sine minus pi respectively. This is 0, we can simply ignore, and this can be written at pi square 64 is to pi oblique 2 minus of minus pi oblique 2. This will nothing but pi. We get pi oblique 64. And what we have to compute? We have to compute 16 pi cube is to the integration, for which we got the answer as pi cube oblique 64. And this will become 1 oblique 4. Our answer will actually be 0.25. So this will be actually 0.25. Right, friends, thanks a lot for joining Maths Maestro. I hope you enjoyed the video and the explanation would have been very helpful to you. In case you want to ask anything, you want to kindly write in the comment, and subscribe the channel and forward it to your friends. Thanks a lot for joining. Bye bye.